Hello, today we're going to look at a simple maths trick that helps us work out the angles inside a polygon, so you don't have to memorise the formula. Now, unless you've been hiding under a rock, you'll know that the interior angles in a triangle add up to 180 degrees. And it doesn't matter what sort of triangle it is, the three interior angles always add up to 180 degrees. Now, if we draw a square, we know that every angle is a right angle, 90 degrees. So we also know that the interior angles of a square add up to 360 degrees. And that's also true for every quadrilateral, whether it's a rectangle, a rhombus, or a trapezium, etc. But what about a pentagon, a hexagon, a septagon, an octagon, a nonagon, or a decagon? Well, there is a formula you can use to work out the sum of the internal angles for any of these shapes, which is n minus 2 times by 180, where n is the number of sides. And if we use this formula, we can see that the internal angles of a triangle are indeed 180 degrees, and a square is 360 degrees. And then using it for the pentagon, we have the interior angles adding up to 540 degrees. The hexagon's interior angles are 720 degrees, the septagon's angles work out at 900 degrees, and the octagon's angles work out at 1080 degrees. But if you can't remember the formula, here's a simple trick that will also give you the value for the interior angles. Now, to do this, we're going to split each shape into separate triangles. So starting with the square, draw a line across the centre of the square and we have two separate triangles. Now, we know that the interior angles of a triangle are 180 degrees and we have two triangles in the square. So we times 180 by 2 and that gives us 360 degrees. Now, moving on to the pentagon, if we split this shape into triangles, we have three separate triangles. So we times 180 by 3, which gives us 540 degrees. As a side note, to use this method, none of the triangles are allowed to overlap. Splitting the hexagon into triangles, we have 4 triangles, and 4 times 180 is 720. We can split a septagon into 5 triangles, and 5 times 180 is 900. And we can split an octagon into 6 triangles, and 6 times 180 gives us the 1080 degrees for its internal angles. So I prefer this method, but it's up to you if you use this or the formula. And even if you don't use it, you could use it to verify you've got the formula correct. Now, there's one other very important piece of information you need to know before we can go on to tackle some questions, and that is to do with exterior angles. Now, an exterior angle of a polygon is the angle at a vertex of the polygon outside the polygon, and it's formed by one side and the extension of an adjacent side, but it's easier to see here in this diagram. Now, this is a regular polygon, and we know the internal angles will add up to 540. This means that every angle inside is 540 divided by 5, so they're all equal to 108 degrees. Now, this orange line is a straight line, so we know the two angles x and 108 have to add up to 180 degrees. This means that x is going to be equal to 180 minus 108, which is 72 degrees. This will obviously be the same for every external angle. So every external angle on this pentagon is 72 degrees. Now, as it's a pentagon, there are 5 exterior angles. So if we times 72 by 5, we get 360 degrees. And this is the important bit of information, that in any polygon, the sum of all the exterior angles adds up to 360 degrees. And now we can use these two pieces of information to start answering some basic questions. So first we're asked to calculate the size of an exterior angle on a regular hexagon. Now, one way to do this would be to first calculate the size of an interior angle. Now, we know a hexagon can be split into 4 triangles, so the sum of all of the interior angles is 4 times 180, which is 720 degrees. We're also told that this is a regular hexagon, so we know that each angle is exactly the same, so one angle inside is 720 divided by 6, which is 120. That means the exterior angle is 180 minus 120, which is 60 degrees. However, there's a much easier way to do this. If you remember from previously, all of the exterior angles add up to 360 degrees. And again, because we know this is a regular hexagon, they're all going to be equal. So each angle is going to be 360 divided by 6, which is equal to 60 degrees. And in the next question, we're asked to calculate the size of angle X in this irregular pentagon. And as we can split a pentagon into 3 separate triangles, the sum of all of the internal angles add up to 3 times 180, which is 540 degrees. But as we know every angle inside this pentagon except X, and we also know that they all add up to 540 degrees, then the angle X is simply 540 minus 125 minus 115 minus 90 minus 140, which makes X equal to 70 degrees. So the good news is you now have all the essential information you need to answer exam questions on this topic. And the bad news is it's not enough to ensure you get full marks in the exam questions. For that, we're going to have to do some more practice questions. Unfortunately, I don't have time in this video as it's already too long, so I'll cover this in the next video. So thanks for watching. I hope to see you in the next video, and meanwhile, if you could hit the like and subscribe, that would be fantastic.